Last week, we learned about the relationships between parallel lines and angles when those lines are intersected by a transversal. Today, what we're going to talk about is using those angle relationships to actually prove lines parallel. So the theorems that we did last week were your conditional theorems. And just to review, the conditional is if P, then Q. So one of those conditional statements was if two lines are parallel, then corresponding angles are congruent. Today we're going to look at the converse of those theorems. And so if you remember, the converse is when we switch the hypothesis and conclusion. So if Q, then P. So we're going to look at these converse theorems and refer to the diagram in the upper right-hand corner. So our first converse is corresponding angles converse, and it says if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. So notice we're saying if we have corresponding angles that are congruent, then the lines are parallel. So looking at that figure, an example would be if angle 1 is congruent to angle 5, then line L is parallel to line M. Our next theorem is the alternate interior angles converse, and it says if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. So we could say if, again looking at the figure in the right, if angle 3 is congruent to angle 5, then line L is parallel to line M. We also have our alternate exterior angles converse. So if two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. So again, if you look at the example up in the upper right-hand corner, one way we could say is if angle 2 is congruent to angle 8, then line L is parallel to line M. And finally, we have our consecutive interior angles converse that says if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. So remember, it's the consecutive interior angles that must be supplementary. So again, looking at our figure, we could say if the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees, then line L is parallel to line M. All right, let's look at some examples applying these converses. So what we're going to do here is we're going to look at the information that we're given and determine if we can prove any lines parallel, And if so, which converse are we using to justify our answer? We won't do all of these examples, but they will all be worked on the copy of the notes that's posted on the Unit 3 calendar. So we'll begin with 1A. So in 1A, we are given that angle 2 is congruent to angle 4. So if you look at those two angles, those are corresponding angles. So because of that, we can prove that line C is parallel to line D. And the converse that we're using is the one for corresponding angles. So it would be the corresponding angles converse. Okay, moving down to 1E. Let me erase these here. Okay. So 1E says that the measure of angle 14 plus the measure of angle 15 is equal to 180 degrees. Since those are consecutive interior angles and they are supplementary, we have enough information to say that line C is parallel to line D. And again, this time the reason is the consecutive interior angles converse. Okay. So for 1F, we're given that angle 11 is congruent to angle 16. Now, those are vertical angles, so they are congruent, but we don't have a vertical angles converse that allows us to prove two lines parallel. So for 11F, we cannot assume or we cannot conclude that any lines are parallel, and obviously there is no converse. And then looking at 11G, we have angle 4 is congruent to angle 15. So the transversal for those two angles is line D. Those are alternate exterior angles, so that is enough for us to conclude that line A is parallel to line B. And our converse is this time alternate exterior angles.